Hey everybody, everyone's still awake? Still have enough energy to hear me pontificate about API design? Because I'm going to warn you, like, this is the most exciting part of the talk. The rest of it is very boring. So yes, my name is Paul Ganssle. I work at Bloomberg. I'm a software developer in one of the New York offices. And I'm also a frequent contributor to open source software. I maintain a couple libraries. Lately I've been maintaining setup tools. I've also maintained dateutil for quite a long time. So as a library maintainer, I spend a lot of time thinking about interfaces, about how programmers are going to interact with my library. And of course, if I were to give you all my thoughts on interface design, this would be a 3-hour talk, not like a 30-minute talk, and that would probably just be getting us started. But so instead, what I'm going to do is I'm going to drill down into one specific aspect of API design, which is what happens when you have several features maybe that have very related functionality, but they have slightly different or fundamentally different even interfaces. Oh, and before I go on, I should note that all the slides are online. You can go on my website under talks. It's up there, so if you want to follow along or you find this hard to read or something. All right, so to start with, I'm going to just go over a couple general principles, and these are recurring themes that are going to come up again and again in the course of the talk. So the first is that related functionality should be grouped together. So that could be namespacing by module. So like square root, the function that could easily be a built-in in CPython, right? No one would be confused if you wrote square root and it just worked. But it's kind of tucked under the math module because there's probably lots of functions that would be like that, and it's nice to not pollute the global namespace. There's also, if you look at the library requests, it has a function called get, and that's obviously way too broad of a name. If you just saw a function called get, you would have no idea what that means. What is that getting? Is it getting something? But in the context of requests, it's pretty obvious what that's going to get. It's going to make a request, and it's going to, request something from HTTP or whatever. The other thing you can namespace by is by class. So one example of that is instance methods. On strings, you have the method strip, which operates on the data in the string. And there's also class methods, like datetime has the from timestamp class method, and that just constructs datetime from a timestamp. So related to this is that interfaces should be discoverable. Ideally, they would be discovered by your users reading your documentation from beginning to end before they write their first line of code and fully understanding all of it. I'm sure you're aware of how often that happens. It's basically never. Much more common is that they're going to just kind of open PyCharm or IPython or something, and they're going to start typing, and they're going to hit tab and just see what's there. And like, if it looks right, they'll do it. Or they're just going to type dir into a REPL on your module and see all the methods or all the functions and classes you have, and just go with whatever's named closest to whatever they want to do. And increasingly, they're probably also going to start looking at the static typing information. So when there's more and more libraries that have static typing, they're probably going to look at the function signatures and say, well, okay, so if I give this the types that it wants, it'll probably do approximately what I want. So ideally, you would keep this in mind when you're designing your interface, because you know that that's how your users are probably going to look into it, and you probably don't want them to be wrong when they make these guesses. So this leads to a related general principle, which is that you should think about function signatures. Maybe you're not using type checking or whatever, but if you're going and writing if you write out the function signature with types and it's starting to get really complicated, that's probably a sign that your interface is complicated. So here's a real life example. I picked something from dateutil because I don't want to pick on anybody else's library. So this is relative delta. It's a sort of offset, a calendrical offset. And if you look at the signature, it has two parameters, dt1 and dt2. They both have default values. And it also has years and months and year and month, and there's a whole bunch more just like that. So if you look at this, I don't think it's immediately obvious how you use this. Like, when do you specify one or the other? The way it's supposed to work is that you either use relative delta with two date times, exactly 2 datetimes, and then it subtracts one from the other and gives you a relative delta for that. Or you specify what all the offsets are in years and months and things like that, and you make your relative delta. But you never mix and match these two things. This is not reflected in any way in the function signature. And I'm really not going to get started on how confusing it is that there's a parameter called years and another parameter called year. This is a massive source of confusion for the users. A similarly a complicated function signature that's complicated in a different way is this toy function called send request. All it does is it takes a request as the first parameter, and then it has this optional parameter called return context. And what it returns is either a response type or a tuple of a response type and a context. So this is a little complicated because, type checkers don't really love this. Maybe you can read it and say, okay, maybe if I pass return context as true, it'll give me that second thing, but I think a type checker is not going to infer how that works, so it'll kind of mess things up. And it's also just in general not a good idea to have the return type depend on any of the logic inside the function itself. You don't necessarily have to return the same type, but you should at least return something that implements the same interface. Maybe it inherits from one type or something like that. So this is another sort of function where that's kind of a code smell. And then finally, this principle is that you should provide explicit versions of magical interfaces. So here is dateutil's parser. Dateutil is famous for having this parser that will just take anything that looks anything like a datetime and give you, as a string, and give you a datetime back. You give it something in words, you can give it ISO, you give it whatever, and it generally gets the right idea. But sometimes it's a bug if someone gives you a datetime in the wrong format, right? So maybe I have a function that takes ISO 8601 dates and not anything else. If I'm given anything else, even if it looks like a datetime, it should be an error. I've added to dateutil the ISO parse function. This is very fast because it only has to consider the one format or the one class of formats. But more importantly, it's strict. So the magical interface is like, I have a datetime, I have a string representing datetime, give me a datetime back. The stricter interface, the more explicit version, is saying, I have a datetime string that is ISO 8601, and you can use ISO parse and get an exception for that. Similarly, there's the strp time that works for that as well. So that's the last principle. And let's look at some examples. So here's an example class I've called coordinate. It represents a position on planet Earth, or presumably another planet. And it's basically just a simple wrapper around 2 floats, but it has this kind of nice string representation where instead of positive and negative, you get north and south and east and west. And you can see I can create this little dictionary of city names and their locations and print it out, and it looks great, right? But what if I don't want to just print this out? I want to serialize it to JSON and then read it back in. I don't have any facility for that built in. So maybe the sort of naive way to do this would be to say, all right, how about I make my constructor take either a string or 2 floats? So I can do that. I have this little isInstance check, and it works, right? If I pass it 2 floats, it'll give me a coordinate back. If I pass it a string, it'll do this little parsing and give me back the good coordinate, right? But if you notice, when we're thinking about the function signature, the API that I wanted was something like this, where I have a coordinate and it takes a string and it gives me a coordinate back, or I pass it 2 floats and it gives me a coordinate back. This is something C++ programmers will be familiar with because it's like function overloading. But Python doesn't have function overloading in the traditional sense. So what the API we actually have is this kind of monstrous thing where we have something that's either a coordinate string or latitude, and that one takes a float or a string. And then we have an optional parameter called long, which has to be a float. And then that gives you back a coordinate. So if you're just kind of looking at this, you're like, well, maybe the first one can be a string and the second one can be a float, and that should work. But it doesn't. Oh, I'm very confused by this. Or maybe saying, well, obviously the first one can't just be like a string thing, but why would the second one be an optional parameter unless it just had some sane default? So I'll just pass it, a number, and it'll probably be 0 for longitude or something, right? But again, that's not correct because you're just looking at the function signature. So how can we get around this? How can we make our interface more like what we want? So the answer is to use an alternate constructor. You have this from string method, and we decorate it as class method, so it's going to take the class that it's called on as the first parameter. And I've basically moved all the string parsing logic into from string, which takes a string as its only parameter, and I've left the constructor alone. So when you look at this, I can pass it 2 floats, or I can pass from string a single string. And the API is a little different from what I wanted, but it's a lot closer, right? It has this coordinate, and it takes 2 floats, and from string takes a single string. And essentially, this is a lot more explicit as well, right? You're not trying to dispatch based on what you pass to it. So another advantage of using class methods is that it follows the normal inheritance tree. So here's another example. I don't know why I was choosing locations or spatial localizing things. I guess that's just where the examples were. So this is a data class called point. It represents some point in Cartesian space. It has x and y, and I want to be able to represent it in Cartesian space, but maybe I want to be able to construct it from polar coordinates. And if you don't know the difference between Cartesian and polar coordinates, it doesn't matter. It's totally irrelevant. Essentially, all you have to know is that there's a mathematical transform that goes from one to the other, and they are both 2 floats, and they both represent the same thing. So what I've done is I've created this static method called polar to Cartesian, and that one takes polar coordinates and gets Cartesian coordinates back. And I've created an alternate constructor called from polar, which takes its arguments, passes them directly to the converter, and then passes the results of the converter into the basic class constructor. So now what I have is I have this point that I can use Cartesian or polar coordinates for it. And if I want to create something that's basically a point, but I want to be able to name it. So I'm going to say it has this name thing, and I want to say 0, 0 is the origin. And that works great. And from polar still works, but from polar is not designed to use to have the name because I didn't think of it, and it wouldn't make sense in the superclass. So in order to get that functionality added back in, all I have to do is override the from polar, and in my from polar class method, I can just take my args and my keyword arguments, and I just add this additional keyword argument called name. I pull that out, pass the rest of the arguments directly into the superclass alternate constructor, right? So I call super inside the class method. I don't know that I knew that you could do this until I made this slide, but it was pretty intuitive. I just kind of tab completed, and it really worked. So what this is doing is it's going to pass as CLS named point to the superclass from polar. It'll do exactly what this guy did right above, and it'll return that for me, and then I can just take that and add my name to it and return that, and now from polar works. So that's one way that you can use the inheritance tree. Another way you can use inheritance for this is you can actually override that static method. Even though the static method has no reference to the class that it's on, from polar has a reference to the class that it's called from. So I can create this point 3D, and this one's basically the same as the superclass, as point, except it has 3 coordinates. And from polar still just takes however many coordinates you give it and passes it to polar to Cartesian. But because what's being passed to the from polar on point is point 3D, then what it's calling when it does cls.polar to Cartesian is it's calling point 3D.polar to Cartesian. So I can customize the behavior either by overriding the class methods or by overriding the static methods that the class methods might call. And you can see this works. If you know how polar coordinates work, that is the correct math. If not, just you can take my word for it. All right, so far we've just been talking about classes, but some of my examples before were not classes, they were functions. And you can't really make alternate constructors for classes, right? But you still have problems. So sometimes you see an API that looks like this. I think this is fairly common. This is a contrived version of it, but this is a function called print text, and it takes either a path or a buffer, like some sort of stream. You can, if you pass it a stream, it will just read what's in the stream and print it. But if you pass it a string, it will interpret that as a file path, open the file path, and then pass the file object that you get to the function itself and use the other path, right? So this has a lot of the same function or function signature issues as the earlier examples, but there's obviously a very good reason for why you would want to do this, right? Which is that the general most extensible version of this function is the one that takes the stream, right? That could take a string IO, that could take a file, it can take anything that implements the file interface. And the file path version of it just has to be a file that's on disk somewhere. But 90, 95%, maybe 99% of the people who use this function, all they are going to want to do is like, I have a CSV here, I would like to print it. Why are you making me do this with open and then passing it to this function? Just make the function work for me. And similarly, we have real examples of functions like dateutil's parse, which have this other issue where we're returning different values depending on different types depending on the logic inside the parser. So in the parser has some ability to ignore things that are not datetime tokens if you pass it fuzzy, but some people want to take those tokens and do stuff with them, so it also has this fuzzy with tokens. So the function signature for this is something that takes a string and it returns a union of a datetime or a datetime and a tuple of a bunch of strings. So again, that's not great. So my solution to this is what I would call function variants. So if you think about the constructor and the alternate constructor, the constructor function is just a function that constructs the class that it is, right? So what if you extended this concept to look at other functions, right? So you can say there are other variants of other functions that are not alternate constructors, but they're just alternate versions of other functions. So maybe we can look at our print text example and say, all right, I will say that this function prints text. If you pass it a string, it prints whatever you pass it. And then I'll have an alternate version, a variant of this function called fromStream that just takes a stream and then prints it. And I can have another one that takes a path, opens that, and then passes it to the stream version. So I think that this is a fairly elegant way to do it. It sort of makes sense, but it's weird. It's not super commonly seen. And to give you a little backstory on the origin of this talk, this talk came from an argument that I was having with a coworker, where we were looking at some function. We were discussing what the interface should be. And I came up with like, oh, well, why don't we just have two versions of it, and one is the dot on the other one. And he was like, that is super weird. That is not Pythonic. And I was like, what does that mean? What do you mean it's not Pythonic? And he was like, yeah, alternate constructors are one thing, but no one uses this. So my secret goal, which is not super secret because I'm telling it to you and it's going to be on video and stuff, is to make it so that everyone is comfortable with this and to start using it so that eventually everyone will like tell me that I was right and that he was wrong. So please go forth and spread the word. And to facilitate this, I've created a library that makes it easy to do this. There are a lot of ways to implement this, but I just wanted there to be some simple syntactic sugar so it can be more Pythonic. So the library is called variants, and how it works is you take your primary and you decorate it with this variants.primary. This works kind of like the property decorator in that the function itself then picks up a decorator. So you do print text.variant and then the name of what the variant is going to be, and you decorate the function, another function with the same name but a different signature. So here I've implemented the primary that just prints whatever you pass it. I've implemented its first variant, which is fromStream, which reads the value of the stream and then passes it to the primary. So these variants can call the primary function. And then I've implemented fromPath, which is the same thing. It opens it interprets whatever you pass it as a file. It opens that path, and then it passes the stream that you got to the fromStream version. So they can call the primary, and they can also call other variants. And here's how it works. It works great, right? You have text, you have it from a stream, and you can read it from a file. So this is an example of explicitly dispatching your function. Sometimes you can do it by class. You can dispatch by class and have something that's more like function overloading. But you can imagine I might also have another version, another variant that's from URL that takes the URL and then retrieves the value and then prints that, right? So now I have 3 versions of this: print text, from path, and from URL. All of them can take a string. It's not super easy to dispatch on the type this way. In fact, if you're just doing it naively, you can't do type. They're all the same type. They're all strings. But when you're explicit about what you want, then you can get the behavior you're looking for. But there is a pattern that will allow you to do implicit dispatch, and it maybe is a competitor to this approach, which is you can use functools single dispatch. You decorate your primary function as a single dispatch, and then you can register different types as to be dispatched to, and you can use the built-in path. So you take whatever your stringly typed path and you pass it to the path object, and whenever you have a path, it'll dispatch to this. And for things that are not in the standard library, you can use some super thin wrapper around it, like a URL that's just a data class that contains one string method. And then you have your implicit dispatch, and it works great with single dispatch. So yeah, never mind, variance is not necessary. But why not both, right? So variance works with single dispatch. You can make something both a single dispatch function and a primary function, and then you can register each of your dispatched functions as variance. And you can see if I pass this a string, it knows to automatically go to the string version. If I pass it a path, it knows to interpret it as a path. Or if I pass it a string that is a path to from path, it will open that as a path. And again, from path is explicit, so I can pass it a string that's not a path, but if I pass it to from path, that will be an error. So we have our magical interface and we have our explicit interface. So we've satisfied that general recommendation. Another thing that you can't really get with single dispatch is you can get variation in return type. So if we go back to our example of the parser with the fuzzy tokens, we have this problem where sometimes it returns a tuple and sometimes it returns a datetime. So how about we rewrite this using variance, and we'll say the primary function will be called fuzzy parse, and it just takes a string, it gives you a datetime back. And then we'll have a variant called with tokens, which takes a string and gives you back a tuple of a datetime and a tuple of strings. So now you have 2 variants, and the only difference is what they return. So that is satisfied. You can also have variation in caching behavior. And I'm not using the library of variants, but this is actually in dateutil in how they handle time zones. So here's this contrived example, which is something that gets a configuration. I decorate it with LRU cache, and what it does is it calls the non-caching variant. So I have another version called no cache that will retrieve it from a file or something, or in this case just prints the words retrieving configuration. So the first time I call get config, it just goes to the no cache version. The second time it hits the cache, and I don't have to retrieve it again. But then if I want to defeat the cache because I want a fresh version, I can just explicitly call no cache. So that's fairly useful. And again, it's magical interface with an explicit version of it. You can also have variation in async behavior. So async is becoming more and more popular, and one of the problems with it is that synchronous functions can't really call asynchronous functions without themselves being asynchronous. So you end up with these whole parallel hierarchies of things where you're sort of repeating all your code. This doesn't help with not repeating the code, but it does help you organize these things, because you can have the main function be an async def, and then a synchronous version of it that's just a regular def, and that's a variant. So myfunc, you can call it. It gives you an async generator. Myfunc.sync gives you just a regular generator. Sort of a wrapping up theme is that syntactic marking of relatedness is kind of is another sort of principle that I didn't really mention. I guess I was saving it for the end here, because you can do this with just a naming convention, right? Anytime you have something that's like a dot, you could just replace it with an underscore and it would work just fine, right? And it's the same amount of typing. But you can't do things like this, because I've written an extension to Sphinx that is aware of these variants. So you can have all your stuff organized and your variants, and then the top-level function will be the top-level element in your Sphinx documentation, and all its variants will be nested underneath it. And similarly, if we go back to tab completion, if you have some flat namespace, see here I've just got two function groups, prime factors and print text. And if I type PRI and then hit tab, I have like just a bunch of functions, and some of them are related to each other. But if I sort of use syntactic marking of relatedness, if I type PRI, then I get prime factors, print, and print text. Those are the three main interfaces. And if I complete to one of them and hit period and then tab again, now I see all the variant versions of it. So as you can see, this enables your tools to work smarter and better for you. So to conclude, I'd like to suggest that you don't take what I'm saying as a given. When I gave this as a lightning talk about the variance library, I started off by asking the audience to tell me why I'm wrong, and that's still in effect. Sure, I want to win that ultimate prize, universal recognition that I'm right and my colleague is wrong. But one thing I've learned from working at Bloomberg is that my colleagues are very smart, and even though I think I've made a compelling case for the use of these patterns and why the variant pattern is a sort of natural extension of other types of namespacing, I think having good interfaces is more important than my pride, so please feel free to come up and tell me why I'm wrong. Though if you're watching this video, Matt, you're definitely wrong. And what would a variance talk be without a variant of the ending slide? So this is variance. You can find it on PyPI and GitHub. I'm happy to see some issues and pull requests. And I'd like to thank Bloomberg for flying me out here and paying for my hotel and all this kind of stuff. It's a great place to work. If you're interested in working with, as I've mentioned before, very smart people. We have engineering offices in New York and London and San Francisco. And you can come talk to me after the talk or go to careers.bloomberg.com. And you can find, again, the slides on my website, and I tweeted it on Twitter. So thanks for coming to my talk. If I have time, maybe questions?
Thank you very much, Paul. We have a few minutes for some quick questions.
Hi there. Thanks very much for that. I'm a big fan of looking for symmetry in my API design as well. I noticed, so if you're creating that coordinate from floats, you call .new, in fact, or you call an initializer. If you're passing a string, you have to call the class method. What do you think about disabling or asking people not to use the initializer and always going through class methods?
I think that it's kind of important to make the. I think that would work if you had. I think that would work if you don't have any obvious main way to make it. But in a lot of cases, there is a sort of main way to construct one of these objects, and then you just have alternate variants. And it's the same with variant functions, right? Where the primary function should do what most people want it to do, and then the rest of the variants should all be enabling corner cases. Like if there's some information that's only available during the execution of the function that some people need returned, you don't want to burden the most of the users with it, but some people will need it, and so you want to expose that. It's kind of like your escape hatch. In coordinates, I think that's a toss-up, right? It could be one or the other, but I think there's a lot of prior art in terms of like most things sort of take literals and then they have an alternate version that parses from a string.
One more question.
I think we have.
With your variants, I was wondering why you chose to, when declaring secondary, put the name as a string in the decorator rather than just reading it from the name you used for the second function.
Oh, well, because the name that you use for the second function would get exposed, because how decorators work is they just call the decorator function on the function itself and then assign that to the name you gave it. So it would work to register that way, but then from stream would be a top-level function. But there is an alternate syntax that I played around with, but I thought it was a little magical, which is that I could have overridden the get attribute on the variant decorator itself. So you would do at print text underscore dot, or at print text dot variant dot from stream, and then that would be a decorator that registers that thing. And that has the advantage of that has to be a valid identifier, but it has the disadvantage of being weird and confusing to people.
All right, thanks again, Paul. We're going to take a quick 5 minutes.